Well, hey everyone. Welcome to another episode of Math with Audrey. So glad that you guys can come on in. Well, right now, we're just gonna get everything all situated. So tonight, we're gonna finally, for me, finish up what I want to do with probability. So the probability of compound events. And after we do that, we're going to be looking at mutually exclusive, and inclusive probability. So a little combination of two things, very similar to what we've been working on for a bit. And it seems like I'm going to be kind of chilling during this late night hour. So, hey, you doing, Melinda? You were just sending me a message. I know. That's what happens when I get a lot of meetings, a lot of discussions, but this is what's going on. All right, so when we have two different events, we have an independent event and we have a dependent event. So the independent event, if you see the word and, that means when we have that one event doesn't affect the outcome of the other. All right. So if we look at our independent events, all right, we're looking at, say, one event does not affect the outcome of another. So one of them I like to use as an example is like weather. All right. So if we're looking at, say that they said there's a 40% chance of rain on Saturday and there's an 80% chance of rain on Sunday. So what happens on Saturday doesn't necessarily affect what's going to happen on Sunday. Okay? It could be just like what happened today. It was supposed to be a rainy day and it ended up the sun coming out, right? No one knows what's going on. All hell's going crazy. All right? But when we're looking at 40% chance of rain on Saturday and 80% chance of rain on Sunday, again, one doesn't affect the other. So when we're trying to find the probability of what is the chance of rain for both Saturday and Sunday, we have to take our 40% as a decimal. So that's where the 0.40 comes from. And multiply it to the percentage as a decimal for Sunday. So 80% is going to be 0.80. All right. So when we multiply these two, we get like 0.32, which means it's like 32% chance of rain on both Saturday and Sunday. So most of the times when they're looking at probability of two events and they're saying and, that means A is one event and B is another event. So we're treating it as two separate things. One doesn't affect the other. So when I see the word and, I'm actually multiplying. So we take the probability of event A and multiply it to the probability of event B. All right. So with that being said, we also have the probability of dependent events. So let me bring it on down here and let me unzoom so you can see everything. Zoink. All right. So dependent events, the outcome of one event affects the outcome of another. Okay. So independent, think about it. Independent lady, doesn't matter how the whole situation is. She's still taking care of her stuff. She's taking care of her bills, taking care of the house, the car, all that. Okay, so one thing doesn't affect the whole thing. But dependent, okay, think about kids being dependents. They depend on you. They depend for everything. So if you do one thing out of sorts, the whole routine is down the crapper, right? So one of the things I like to say that some people usually do for probability is when you're drawing a card from a deck and you don't put it back and you don't return it. So you'll see examples like it could be balls, it could be marbles, it could be cards, any of those things like, okay, I took one, but I didn't replace it. So that's going to change how many people or how many places or how many items are going to be in that sample set. Okay, so things are going to actually change. So if I want to look at the probability of getting a heart and then a club, Okay? So I need the probability, and we're saying that there is no replacement. This is your key. This is how you know that you're going to have a dependent event. If they didn't say there's no replacement, so I need to take a look at the probability of getting a heart. So if we recall, oops. Okay, so if we recall our standard deck of cards, especially for those that don't know, here we got our hearts. All right, so out of a standard deck of 52 cards, 13 of them are going to be hearts. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we have 13 of them that's going to be hearts. So we have 13 out of 52. So we pulled that hearts card out of the deck. So that means for the next part, which is the clubs, we don't have 52 cards because we pulled one of them out. We actually have 51 cards because that card that we pulled for the hearts, we didn't replace it back into the deck. But the number of clubs we're going to have is still going to be 13. Okay, because the first card we pull is a heart. The second one is going to be a club. So there's 4 suits. Okay, all 4 suits. Your diamonds, your clubs, your hearts, and your spades, they each have 13 cards represented. Because 13 times 4 gives me what? 52. All right. So with that being said, since we didn't replace that card, that's why it's a 51, okay, instead of a 52. So for us to find the probability, we're going to multiply the numerators, which gives me 169. Then we're going to multiply the denominators, which gives me 2,652. And with our division and multiplying by 100 because we wanted to get a percentage, we got 6.37, roughly, that's approximately, percentage. Okay, that's the probability that as a percent to get a heart for the first drawn card and then a club for the second drawn card. All right, how are we doing? Okay, hope we're doing all right. So now, if we take a look, I think I could fit it all in. Nope, I can't. I can now. All right. So, a bag containing 8 red balls, 12 blue balls, insert jokes here, 9 yellow balls, and 11 green balls. 3 balls were picked out at random and not replaced. Okay? So, if they're not being replaced, now for us picking one of those balls out, okay, it's going to affect your sample space. And that's what it is going to do. So, we want to know the probability of picking a red, then a blue, then a green ball. So if that's the case, we want to know what the probability of getting a red. We see here that we have 8 red balls. So it's going to be 8 out of the total number of balls. So we have 8 and 12, so that's 20. Plus 9 and 11, that's 20. So 20 plus 20, that gives me 40. Okay? So with us having 40 balls, okay, so 8 out of 40 is going to represent the red balls. 8 40ths could be reduced, okay, to 1/5. But for right now, let's just kind of get everything out of the way. So this is the probability of 1. Now, the probability of getting a blue ball, okay, so we took one of the balls out and it's not being replaced. So that means we have 12, but not out of 40 because we took one ball out that could have been red. So that means we have 39. Okay, we have 39. Good. All right. Oh, thank you, Lulu. All right. Yes, Pog. Yes. So now we're going to go with a green ball. So we have 11, but there's not 39 balls anymore because we took one out here, we took one out here. So that means we got to 38. All right. Good. I don't want to hear statistics. Brandon, you're going to hear it. All right. So now we just have to multiply straight across. So we can whip out our handy dandy calculator. All right. So we have 8 times 12 times 11. That gives me 1,056. And then if we do 40 times 39 times 38, that gives me 59,280. So this is the best part. If I go 1056 divided by 59,280, I get this crazy little decimal. But if I hit my math button, right? If I hit math and I want it to be reduced as a fraction, I'll just hit enter for frac and then enter again. It will reduce my fraction. Look at technology. Okay? Now, if you don't believe me, you could, since they end with 6 and 0, I know it's going to be even. So we could reduce it by an even number, but the even number that you can use is a 48. Okay, so the number that you can use is a 48. But my final answer, the probability, is 22 over 1,235. So this is my probability of getting a red, I'm going to say R, red, blue, and a green. Okay. Oops. There we go. Now, same information, different probability. Okay, good, honeycomb. All right. Okay. So now, same situation, different probability. So this time we want to find the probability of a green, of a yellow, and then a yellow again. So the probability of getting a green. So we still have the same 40. Getting a green is going to be 11. So it's 11 out of 40. For us to get a yellow, it's going to be 9. But remember, we picked the ball out and we didn't replace it. So that's going to give me 39. All right. Oh, thank you for the heart me. Hey, Lynette. So now, this is the thing that we have to pay attention to. So we had 11 green. We have 9 yellow. But we're picking a yellow again. So since we're picking yellow again, not only are we going to have 38 balls, but we're going to have 8 yellow balls. Because this first one here represented us picking a yellow ball. Good. That's it, Pog. There you go. So this is like a review of like Algebra 1. All right. So then we have 8 out of 38. Yes. So now, handy dandy calculator. So if we have 11 times 9 times 8 gives me 792. And the denominator, since we already calculated the denominator here, we get the same exact down here. So we don't have to go and do that over again. So now, let's see if this can be reduced. Both of them are ending in even numbers. So there is a possibility. And yes, we do. So we have 33 out of 2,470. Okay, we can do it as a decimal, but if we do it as a decimal, we're going to be doing some rounding. So we're not going to give its true value. So we want to keep things as fractions as much as possible. All right. Do I tutor trig? Yes, I do. I do identities and verifying. Yes, I do. Okay. Especially when you're using with the negative x. Okay. All right. So this is basically what we're doing. Okay. But anytime they say not replace, that's going to be huge. You got to make sure each and every time that you're doing a separate probability, make sure you're descending, taking at least one of those away. All right. So dependent events depends. One event depends on the other. That's what these are. Independent events, it doesn't affect. One event does not affect the other. All right. Okay, how can I show in a message the things I need help with? You won't be, I mean, you could type it, but I'm not going to do individual stuff tonight. I just want to hit on all the probability, but maybe for the next one. Okay. All right. All right. Carolina, thank you. I appreciate it. Oh, okay. Not me for tonight. Yes. Yep. You can just put it right in the chat. So now, thank you for the rose. I appreciate it. Thank you. Okay. I'm going to be working on subscription, but I'm also going to be working on like free content as well. So I just came in a meeting that was awesome. That's giving me some ideas because doing all of this prep work, guys, it's a lot. It's a lot. All right. So now, a bag containing, let's see if I can zoom in just a hair. So a bag contains 2 red, 6 blue, 7 yellow, and 3 orange marbles. Once a marble is selected, it is not replaced. Find each probability. All right. So first off, before we do anything, what would be my total? 2 red, 6 blue, 7 yellow, and 3 orange. What would be my total? Hey, Layla. Okay, so honeycomb is telling me 18. Do we agree? Okay, and I have 18. Is it Elos? Hey, Luca. All right, so we got 18. So if we're looking at, say, number 16 here, and we want the probability of 2 oranges. So that means the probability of one orange is going to be 3 out of 18. And yes, 3/18 can be reduced. Okay. Now, so if I took 3/18, what should be the next ratio? Okay. So we started off with 3 oranges out of the 18. What would be the next ratio? The probability for the next event. Let's say 2 out of 17. Is it Elisa or is it Alyssa? Is it the first one or the second one? Elisa or Alyssa? Or neither? The second one? Oh, okay. I was like, or neither. I'm like completely messing it up. All right. Okay, Alyssa. Yes. So, because we had 3 out of the 18 oranges when we first picked. So that means we didn't replace it. Remember, it says not replaced. So that means we're not talking about 18 oranges. We're talking about 17. And since we already picked one of the orange, that means we don't have 3 in there anymore. We have 2. So now we just have to multiply. So we have 3 times 2, that'll give me my 6. But I'm going to need the handy dandy for the 18 times 17, which gives me 306. So combination, you don't need order. Permutation, you need order. So permutation is great when they said, we got 3 people that want to take position of office, which would be president, vice president, treasurer. Let me just put it that way. And there's 6 people that's applying for those 3 spots. What are the combinations you can have? That's permutation because you have a president, you have a vice president, and you have a treasurer. So they have to have a certain amount of order. Same thing happens when it talks about a race. Like how many combinations will finish the top 3. So that's permutation. Combination is like you going to, I don't know, Five Guys. If you don't know what Five Guys is, it's like a hamburger spot. You can have whatever you want for your burgers. So if you want, you can have jalapenos on there. You can have different types of cheeses. You can have different types of lettuce. You can have fried onions, raw onions, pickles, relish, A1 steak sauce, salsa, whatever. You can get all different combinations, okay? With deciding whether order matters or not, okay? So if they're talking about like putting in a mixture, putting outfits together, that's combination. Permutation is what are the different combinations to finish the first 3 in a race. There's people that want to hold place of office of president, vice president, treasurer. Okay. All right. You good? All right. Cool. Sometimes I can't tell if you guys are like, you got it, because I'll keep rambling on. All right. So, but 6 over 306, this can be reduced. It can be reduced, I think, by 6. Yep, by 6. So this will be 1 over 51. So the probability of picking 2 oranges is going to be 1 out of 51. So for 17, let me see if I can change colors so you guys can see it better. All right, so for 17, the probability of getting a blue, then a red. So getting a blue is 6 out of 18. Okay. Then a red, which is 2, but it's not out of 18. It's going to be out of 17 because once they pulled that marble out, it's not being replaced. All right. So 6 times 2 will give me my 12. And then we already did 18 times 17 before, so that gives me a 306. So since 12 and 306 are even, that means it definitely can be reduced. And this is reduced by 2 51st. Because if I divide it by 6, 12 divided by 6 gives me 2. 306 divided by 6 gives me 51. Okay. All right. And let me box my answers. Okay. Number 18. So with number 18, I'm going to put it right here. They want us to find the probability of 2 yellows in a row, then an orange. So 3 marbles are being pulled. So the first one is a yellow. So we have 7 out of 18. The second marble we're going to pull is also a yellow. So instead of an 18, it's going to be 17 because the marbles haven't been replaced. And since we already pulled one of the yellows out, instead of a 7, it will be a 6. And then the last one is going to be an orange. And the orange is going to be 3 oranges because we haven't pulled any oranges out. But it'll be out of 16. Okay. So, what is my probability? What do you think? Hey, Jay. Okay, 7 times 6 times 3. That will give me what? Kiwi cat. 7 times 6 times 3. Okay, thank you. Will give me 126. And then we know 18 times 17 is going to be 306. So we already got that. What's 306 times 16? Okay. Hey, Blessed RN, how are you? Yes, probability. Just kind of getting through it. This is the last part of probability for moi. And then I'm going to probably go back to what I did last night. And if any of you guys are going through the nursing program, okay, and you want to learn a cool way how to basically calculate dosage without doing a whole lot of math, make sure you guys follow a Blessed RN. She's amazing. And I know I always, at the end of my sessions, I always put everybody in. So these are the people I always ask at the very end to follow. So I got a list. Right? I always got a list. Yes. All right. So we got our 126 divided by our 4896. Both of them are even, so that's telling me this can be reduced. All right, so if I do my 126, this can be reduced actually by 18. So if I divide both the numerator and the denominator by 18, that should give me my answer, which is 7 over 272. So that would be my probability of getting 2 yellows in a row and then an orange. Yes. Yes, you are. You're definitely on the list. I give praise to people. I always do. I always do. It's just a thing that I do. Because when I see greatness, I always praise it as best I can. So, number 19. Okay, so when it comes to 19, the probability of getting a blue, then a yellow, then a red. So, blue, we have 6 out of a total of 18, which I could reduce that to 1/3 if I wanted to. Okay. Then the probability of getting a yellow, it's going to be 7, but not out of 18, but out of 17. Because remember, it's not being replaced. And then lastly is the red, which we have 2. So there's not 17 marbles in there. Now there is 16. Okay, now there's 16. Well, thank you for liking the live. Appreciate it. So this denominator is exactly the same what we got here because we got our 18, 17, 16. So that's helpful. So we know our denominator is going to be 4,896. But my numerator, we have 6 times 2, which kind of gives me 12. And 12 times 7, that gives me 84. And since we have even numbers, we're going to see if they can be reduced, which they will be. And my probability of getting a blue, then a yellow, then a red is going to be 7 out of 408. So 700, 408. Okay, good question. So what's happening is we have 18 marbles in a bag. And the main thing is once a marble, I'm not sure if you can see that. So once a marble is selected, it's not replaced. So first we start off with 18. Then I pull one of the marbles. Yeah, there you go. So now I got 17. Then I pulled another marble. Now I got 16. Yes. So now we're actually dealing with different events. Okay? So this is a dependent event because the total amount of marbles left in the bag depends on how many you're pulling. Okay? So that probability is going to switch up based on us not replacing. If the marbles are being replaced, yes, it would have been 18, 18, 18. Okay? Because the numbers of marbles would not have changed. All right? Good. Okay. All right, so I would like to, because I feel like I'm beating a dead horse here, I would love to skip to this question. I know. As a teacher, I loved these type of questions. Find the error. Okay? Thank you. I appreciate it. Okay? So find the error. So this is what's happening. On the school debate team, 6 of the 14 girls are seniors, and 9 of the 20 boys are seniors. Chloe and Amber are both seniors on the team. Each girl calculated the probability that either a girl or a senior would randomly be selected to argue a position at the state debate. Who's correct? And explain your reasoning. So we have Chloe here that's saying the probability of getting a girl or a senior is going to be 14 out of 34 plus 15 out of 34 minus 6 out of 34. Whereas Amber saying that the probability of a girl is 6 out of 34 or senior 15 out of 34 minus 14 out of 34, which gives her 7 out of 34. Who do you think would be right? Which one feels right? Because I know I haven't taught this part. That's going to be the next section. So I just want to see what you guys can do before I jump on in. So who do you think is right? Chloe or Amber? You can use C for Chloe and A for Amber if you don't want to type all the words out. You can take that as well. Okay. So Christopher is saying that we have a total of 34 boys and girls. Okay, so Christopher, you gotta make a decision. Chloe looks right, but I think Amber's right. So which one? Do you think it's Chloe or Amber? Okay, remember. I know, you gotta make a decision. It's like, we're not trying to go back into the days of TFs. Okay? If you're too young to understand what this means, we can still talk. But remember, that used to have an effect when I was going to school. It's like, well, it's not wrong. I did say truth. It's either true or false. Well, I can make a decision. So, no, that's not an F. That was a T. That was a random line. Oh, no, that was an F. Right? Used to do that all the time. All right. Well, hey, I know the things we do. All right. So, who is it? Do we think, is it Chloe? Excuse me. Or is it Amber? Who do we think has it correct? Yeah, I gotta bring it back, Once in a while, I gotta bring it on back. Oh, hey, Janice. Hey. All right, so you made a decision with Amber. All right, good job. All right, Baked by Eve, how are you? Welcome in. So I got one. All right, got two people. Oh, we got one for Chloe. All right. Ooh, it's dead center. Hello, Melvin. What do you think? Is it Chloe or is it Amber? Oh, we got an A for Amber. All right. I got 6 girls, 34 boys and girls, and then so on. Okay, we got Monica with Amber. Got Kevin with Chloe. Hello, Kevin. Pleasure to see you again. Yeah, so it looks so right. Okay. Oh, got Chloe. All right. So we're almost dead center again. And how are you? I think it's magenta. Okay. All right. One more vote. One more, and then I'll show. One more. And if you want to tap while we're waiting for that one more, that would be amazing. Let's see if we can get to 3K. Let's see. There's 18 of us. Let's see if we can get to 3K. And then I can show where we're going here. Mi gente? Okay. Got you. All right. So sorry. Mi gente. All right. So you're saying Chloe is like, I would want to do some math right now, but I just did my state test. Oh, I know. Your brain is done. I get it. Not a problem. Not a problem. Because we're probably going to be working more on graphing linear equations again and talking a little bit about point slopes. So I definitely know. I'm going to probably see if I can go back to going live twice a day. I just have to rearrange my schedule a little bit. All right. Oh, we thought we had Chloe, and then all of a sudden. All right. So we have Chloe. Girl and senior, so the probability of a girl plus the probability of senior minus the probability of both. Just a player. Go ahead. Players are going to play, baby. All right. Oh, thank you. Love it. All right. So we got one more. I got like 2.9. I need 3. If I get 3, then I can go to the answer. The answer. Oh, we're almost there. Keep tapping. Do not be stingy with your love. There we go. All right. All right. So the answer bing, is Chloe. What? How? Well, just like a player just said, okay, we want to get the probability of a girl. So we said here, 6 of the 14 girls are seniors, okay? So we got 14 girls, and then there was 20 boys. So all together was 34 girls and boys. So if we're doing the probability of girls, it's going to be the 14 out of the 34. Boom. Okay. The 6 that Amber has, the 6 is supposed to be 6 of the 14 girls are seniors. Okay. They're just looking at the seniors. They're not just looking at the girls. Plus 15 out of 34. The 15 out of 34 is the seniors. So that means we had 6 of them are girl seniors. 9 of them are boy seniors. So that will give me 15 out of 34. That will be all the seniors. But we have to take away the fact that there are girls and seniors that are being counted twice. Okay? So what we have to do is take away the ones that are a combination of both status, that they're a girl and they're seniors. Well, there's 6 out of the 14 girls are seniors. So this is the 6 that we need to put out of the total, which is the 34. Okay? Probability of girls, probability of seniors, and then the probability of both. We need to pull that out because right now we got a couple people that are being counted twice. Actually, not a couple, 6 of them are being counted for twice. All right. So you got your 14 plus 15 minus 6 will give you your 23 out of 34. Yes. Look at you, Janice. All right. Okay. No way. Yes way. Okay. So this is going to lead into our next area. Okay. It's going to lead to our next area, which you guys are doing awesome. All right. Flipping it up. So our next area is going to be our mutually exclusive and inclusive events. All right. Mutually exclusive and inclusive events. For college. Yes, I try to keep it nice and chill as best I can. All right. Still waiting on that book? I know. All right. So, mutually exclusive events. Okay. Events that cannot occur at the same time. All right. There's a couple things that people can't have at the same time. So, like, say, math wise, if we want to say, if you roll a dice, okay, just one die. If you roll it, you can't get a 1 and a 5 at the same time. Not possible. Okay? Not possible. So you can try, but hey, this is cards. It's a combination of middle and high school. Okay? It's a little bit of Algebra 1, especially second semester Algebra 1. All right? And then probability in itself, the intro to statistics. So, mutually exclusive, you can't have two things occurring at once. Okay? So, a card is drawn from a standard deck of cards. Okay? Standard deck of cards, that means there's 52 cards in that deck. What is the probability that the card is a heart or diamond? All right. Probability that it's a heart, going back to my lovely little chart, okay, as I mentioned, with all the hearts, there's 13 of them, okay? Each suit has 13 cards in it. Your diamonds, your clubs, your hearts, and your spades, okay? So each of them have 13 cards into it. So the probability of getting a heart is 13 out of 52. So the probability of getting a diamond is 13 out of 52. Okay? So you can't get a heart and a diamond at the same, well, if I have one card, I can't have a heart and a diamond on the same card. It's got to be one or the other. So the probability of me getting, since I see this word or, okay, anytime you see this word or, you're not going to multiply your results. Okay, that's what's different. Let me show you. Okay. That's what's different. Oh, here I go. Right here. Right here. When we want to separate our two events, we use the word and. If you see and, you're multiplying. See the word and, you are multiplying. Okay, so if you see the word and, you're going to be multiplying. But when you see the word or, oops. But if you see the word or, you're adding. Okay. And is going to be multiplying, or it's going to be adding, addition. So if I want to find the probability of hearts or diamonds, that means I'm going to take my 13 out of 52 plus my 13 out of 52, and that's going to give me my 26 out of 52. And what's 26 out of 52? Oh, Christopher, thank you for all these gifts. Where's the 52 coming from? That's how many cards is in a standard deck. There's always 52 cards in a standard deck. Okay? So that's how many total. Yes, Frankie. Love it. So 26 out of 52. 52 divided by 26 is just 2. to the probability. And plus that makes sense. You know, there's 4 suits. There's hearts, there's diamonds, there's clubs, and what am I missing? Spades. Okay? So if there's 4 different suits, and your probability of getting a heart and a diamond, that's going to be at least half the deck. So that makes sense. All right? So sometimes you don't have to give all of this. Oh, thank you, Janice. I appreciate that. So much. Love the gifts. Christopher, you went crazy with the gifts. Thank you. All right. So that's mutually exclusive, okay? One thing can occur at the same time as the other, okay? So I can't just flick one card down and I get a heart and a diamond from that one card, okay? I can get a hearts club, a card, I can get a diamonds card, but I can't get both of those suits in one card, okay? Yep. Why are you up so late? Because I feel like I want to teach. I don't know. I just felt like teaching. You ever just get that way? You just want... I don't know. Lately, I've been feeling like I've been running out of time. I don't know what it is. I don't know if it's just the way the world is right now. But I'm going to teach. If people are willing to learn, I'm willing to teach. All right. Now, inclusive events, the best way for me to describe it is with a Venn diagram. This was like the only way. Well, not the only way, but this works. Inclusive events is similar to what we were just talking about with Chloe and Amber. All right? So we have things that's in event A. We have things that's in event B. But then there, as you can see, it overlaps. So since there's some overlapping, we gotta have to subtract that away. Now, sometimes it just seemed like, all right, I'm subtracting the same thing and my answer is just the probability of B. That's gonna happen, okay? I'm gonna show you what I'm talking about in a second. Okay. So, the night owls. All right. So with the inclusive, you're talking about the ones that are basically taking a little bit from column A and a little bit from column B. Okay. But we have to subtract that in order for us to get our true probability. All right. So let me come over to here. And then let's see what we got here. Okay, so we have one card is randomly drawn from a standard deck. Find the probability. All right, so I want to look at the probability of diamond or a club. I know, really emphasize that or a little bit. All right, so this is very similar to what we just saw before. What's my probability? What did I say? What did she say? She said something? Yes. What did she say? So the probability of getting a diamond and a club. What would be the probability? There's 4 suits. Yes, Pong. Just reduce it a little bit. There's 4 suits. Diamonds and clubs are 2 out of the 4 suits. Sorry, had to get some water. Can I do polynomials one day? Sure. It might be a Friday one. It might be. Okay. So it is. It's half the deck. Exactly. So yes, we could have done our 13 out of 52 cards. Then we're going to add the other 13 out of 52 cards. Okay? But we can't have a diamond and a club on the same card. So there's nothing we got to subtract. So it'll just give us our 26 out of 52, which can be reduced to 1/2. Okay? Or just think about it. There's 4 suits. We're talking about 2 out of the 4 suits. Just reduce it to 1/2. Okay? Yeah, because exactly, it's half the deck. Right? So sometimes if you're taking like a GED, Accuplacer, ASVAT, and they give you a question like this, I know you're going to be excited because, oh, I don't want to screw up. I really want to score well on this test. And the more that you panic, the more likely you're not going to do well. If you ever notice, like for me, the days that I do extremely well with any of my tests were the days that I was either sick or I was just sick and tired, right? You know what I'm talking about. I just want to burn this whole place down. You know, you ever just get to that point in your life, right? The days that you just don't care, you do well. You will do extremely well. All right? So now, let's take a look at the next one. Heart or red? Okay? A conditional probability problem. So if then? Okay. All right. Okay, mi gente. There we go. I gotta get it. All right. Okay, so wouldn't you just do the regular probability? So is always part of the whole? Because even if they give you conditions, it's still going to be part of the whole. Okay, mi gente says it's going to be 1/2. So you're saying 39 out of 52? All right, well, let's see. Yes, there you go. So you have your probability of getting a heart. So if we get a heart, that's 13 out of 52. Okay, since it's an or, we got our plus. For us to get a red card, that's going to be 26 out of 52. But isn't heart a red card? Okay, so for those that don't know, because sometimes I keep forgetting, I keep assuming that everyone plays with cards. Let's go to the chart. To the chart. Okay, look at my hearts. All my hearts are red cards. So we have a combination. So we know that 13 out of those 52 cards is going to be a combination of red heart cards. Okay, because that's what they are. So once you do your 13 minus your 13, what's left over is your 26 out of 52. And 26 out of 52, that's equivalent to 1/2. Okay. Hey, Pedro. Welcome on in. All right. How are we feeling? Okay. How are we feeling? We got some thumbs up. Can we be friends? Light up the gallery? What gallery? Okay, good. All right. So now, let's try to find the probability of getting a 10 or a spade. Okay, give this a try. Okay. The probability of getting a 10 or a spade. Let me see if I can raise it up, and I'll leave this one up so you can use it as a reference. And when you're done, put your answer in the chat. And if you're done early, go ahead and tap. Tappity tap tap. So I'm seeing I'm seeing 16 out of 32s, 15 out of 32s. I mean 52s. I think I said 32. Well, no, one says 32, but it's really 52. Got you. So I'm seeing 16 out of 52. And time doing this. That's all right. Okay. So 4 plus 13 minus 1. Okay. All right. This isn't that bad. See? It's not killing you. All right. So, a deck of cards. So first they're asking for the probability of 10. So here's my 10s. There is 1, 2, 3, 4 cards out of a full deck of 52. So the probability of getting a 10 is going to be 4 out of 52. Plus the probability of getting a spade. So you have your spades right here on here. And like I said, all suits has 13 cards in there. So it's 13 out of 52. But take a look. There is one spade, get it right here, that's a 10 and a spade. So there's 1 out of 52 that we need to take out of the mix, because right now it's being counted twice. One for a 10 and one for a spade. So we need to put that where they have both criterias put together. So we got to subtract that out. So 4 plus 3, that gives me 17. 17 minus 1 gives me 16. So 16 out of 52. And this can be reduced by 4? 16 divided by 4 will give me 4. And then 52 divided by 4 will give me 13. Okay, so that's the probability of us getting a 10 or a spade from a standard deck. Okay, get it now? Good. So I like to kind of put it, it's always when you set up your ratios or your exponent, not your exponents, or your fractions, is you want to take the part over the whole. What you're looking for over the total amount. Okay, what you're looking for over the total amount. Okay. All right. So, based on time, and plus me starting to get a little bit loopy, I'm going to skip down to this little section where a student is selected at random from a group of 12 males and 12 female students. There are 3 male students and 3 female students from each of the 9th, 10th, 11th, and 12th class grades. Find each probability. All right, so I'm going to get you started. So, for the first bit, how many total students are we talking about? That's the first thing. We should always put the total down. There you go, FC, good. Okay. So, since we have 12 males and 12 females, we're talking about 24 students right off the bat. Good. So now they want us to find the probability of a 9th grader or 12th grader. Okay? So for number 9, first thing, we need the probability of a 9th grader. So they said there's 3 male students and 3 female students from each of the 9th, 10th, 11th, and 12th grade. So how many students are in the 9th grade? Look at FC. Look at FC go. Okay, how many students would be in the 9th grade? Part over the whole. Yes. There's 3 males and there's 3 females. So there's going to be 6 out of the total number, which is 24. Okay. So there's 3 for the females, but there's also 3 for the males. So it will give me a total of 6. Right? So 6 out of the 24 in 9th grade. Plus, and the reason why it's plus, because we're using the word or. My 12th graders. Okay? So how many 12th graders? Okay, 3 each. Yep. So 3 each. Same thing's happening with the 12th graders. You got 6 out of your 24. Okay, so 1/2. Yes, because 6 plus 6, that'll give me my 12 out of 24. 12 24s can reduce to 1/2. I know, we got a lot of 1/2s going on around here. All right. Yes, mi gente. All right. Hello, Kim. All right. So for number 10, they want us to do the 10th graders and females. Okay. So the 10th graders, we know, because each class is basically going to have 6 students in there. 3 boys and 3 girls. So that should be the norm, the 6 over 24. But we also need, since they say or, it's plus, the females. Okay? What will be my females? Not the 15 out of 24. There we go, Pog. Good job, Pog. There we go. So for the females, they're telling us there's 12. And there's 12 out of 24 students. Okay, and there's 24 students all together in that group. But is it possible for us to have a couple people that are female and in the 10th grade? Is that possible? So if they're saying there's 3, good. So if they're saying there's 3 female students in each of the grades, and we're looking at 10th graders, that means we need to subtract that 3 out of 24. Because we have 10th graders and we have females, and we do have 3 people that identify as females and 10th graders. So, common denominator, so that stays the same. Okay, 6 plus 12, that gives me 18. 18 minus 5 gives me 15. So 15 24ths, yes. Yep. So FC, you were right. Mi gente, you were right. Okay. So 15 24ths. And it can't be reduced any further. All right. Number 11. The torture is almost over. Are y'all? Can you feel it? Can you feel it? All right. So number 11. Let me see if I can change colors here. So, the probability of male or female. What would that be? The probability of male or female. Pog, I'm telling you. For a person that has never seen this before, I'm wondering if there's some fibbery afoot. Right? So we have a total of the 24 talking about the 24. So 24 divided by 24, that gives me 1. Right? Common sense. Yep. Yep. So it's just going to be 1. And last but not least, maybe I'll leave you guys alone with this one. Maybe that's what I'll do. So number 12. Come on, confidence. We have the probability of male or not 11th graders. All right, C-Pro. C-Pro? Okay. Oh, Janice, thank you. You don't have to. I appreciate it. I think this is like the most gifts I've gotten in a life, to be honest with you. This is awesome. Okay. So we have one person for 21 out of 24. Okay, you agree a little bit? All right. Stuck. If you're stuck, go ahead, question mark. Remember, question marks are answers too. Okay, not sure where to go, what to do, something funky happened. Yep, Put it in there. FC is also saying 21/24. We have an 18 out of 24. Okay. All right. So first, the probability of us getting a male, that's 12 out of 24. Or, which is my plus sign, not 11th grade. So not 11th grade, we're looking at 9th grade, we're looking at 10th grade, and we're looking at 12th grade. All right? So if we're supposed to basically have 6 students in each of those grades, the reason why I say 6, 3 males, 3 females. So not in the 11th grade, that means we're looking at the 6 that's in 9th grade, the 6 that's in 10th grade, and the 6 that's in 12th grade. So, I don't want to conjure them up, but if I add those numbers together, I will get 18 out of 24. But there are some males that are not in the 11th grade. Okay, so we have a combination. So that combination deals with the 3 that's in 9th grade, the 3 that's in 10th grade, and the 3 that's in 12th grade. So 3, 3, 3. That gives me, am I saying that's right? 3, 6, 9, yeah. 3, 3, 3, 6, 6, 9. Out of the 24. Okay, 12 plus 18, that gives me 30. 30 minus 9 gives me 21 out of 24. Okay, nice. Okay, so you can honestly say, I've seen this before. I know how to figure out compound inequalities, so independent events, dependent events, as well as your mutual exclusive, there we go. Yeah, you can tell it's time for me to shut down because I think the right side of the brain is like, and we're gonna just stop in like 2 minutes. Whatever you say out your mouth is just gonna be entertainment. You might get arrested, but it'll be entertainment. All right. So let's flash up. See if I can get all this stuff in here. If you want, whoops. Okay, take a quick snapshot of it if you want it for your reference. I'm going to take it down in 5, 4, 3, 2, 1. Okay, going to the other side. All right. And I will be taking that down in 5, 4, 3, 2, 1. There you go. All right. So, okay, so we got that part down. Now, if you like the design of this notebook, guess what? I created this notebook. All right. Yes, I use a lot of other people's writings and stuff like that. Did graphing linear equations. That's what we did last night, but we're going to do some more with that, as well as some polynomials. And there's like 100 of these pages in here where you can take your notes on one side and also the grid part on the other side. And I also have reference sheets. So with this reference, if multiplication is not your jam, don't worry, I got you. Here is the factor sheet that you can help you with multiplications. Tell you all the factors from 1 all the way to 200. So if you want to break down radicals, if you want to do factoring, this factor sheet is what you need. Okay, so we have our words. We have, for most word problems, we have the rules for integers with addition, subtraction, multiplication, and division. We also talk a little bit about the linear. So we got our equation of line, we got our quadratics, we got our properties of exponents, the order of operations, as well as a little bit of geometry, transformation, and properties of quadrilateral. And then I know a lot of kids are kind of in this section now because I've been doing a lot of tutoring on volume and on surface area. That's here. Also the definition of the circle, the arc length, which is this one, and then the sector, as well as Pythagorean's theorem. So all these resources that's coming in, and also the unit circle for advanced kids. This is designed for students 7th and up. There's 3 different covers on Amazon. You can go to my website, click on the Ultimate Support Notebook, or Ultimate Support Notebook, the Ultimate No Math Notebook. And the covers are different, but the internal stuff is exactly the same. So just get yourself nice and organized. It gives you a section to write down formulas and also some steps to kind of help you along the way. And then with the different colors and everything, yes, I will be getting myself together to do like a answer booklet. So all my notes you can actually get. So cheap rate, really low. I'm going to keep it low. Okay. All right. Good. Perfect. Okay, so if you go to my profile, you go on ACG Math Tutoring, my website, and then you can just find the Ultimate Math Notebook. Now, if you are new and you actually liked what was going on today, a couple other ways that you can support me before I start going into a subscription. And I'm thinking that the subscription is going to be really geared towards those that are currently taking some of the exams. Like they're going to take it like really soon and they just need to get some extra assistance. So I'm thinking about doing the subscription. But also I am going to have a free version. Okay, there is going to be a free version, a free live. So I'm not going to, leave you in the lurch. All right, it'll definitely be a heck of a lot cheaper than one-to-one tutoring. Okay. All right, yes. So if you can do a Google review for me because this is basically like tutoring. I want to kind of get my numbers up on my Google platform, as well as subscribe to my YouTube channel. So once I get off here, I'll be up for another couple hours to download this lovely video. So once the video is downloaded, I put it up on my YouTube channel, Audrey Codner ACG Math Tutoring. Go ahead and subscribe. Don't just fish around there looking for free stuff. Subscribe. I mean, it's really, really free, right? But that can help out a lot. Now, my live schedule, I got to look at it one more time because I keep getting more clients, things keep getting shuffled around, and now that I really want to go back to what I used to do, which was go live twice a day, there's going to be certain days that I can go at 1 o'clock, and there's going to be certain days that I cannot. So I just have to finagle it and just pray on it. Okay, but once I get it, I will make a post of it, and I will actually pin it to my comments in my profile. There we go. Told you, brain is starting to shut down. All right. Well, thank you so much, guys. If you have any questions, and if anything, I know my friend Lynette is probably on. If you want to learn how to use the abacus to learn how to add, subtract, multiply, and divide, she's about to release 2 books. So she already got them published. Or they're just waiting for the final tidbits. And then she's going to release 2 more books to help with multiplying and the powers of 10. All right. And if you need a chemistry tutor, go to Professor TK. She is amazing. And then if you want more practice on the TEAS test, the ASVAT, the GED, on days especially that I'm not presenting or I'm not on, at least you can still get some assistance. She's really good. So Miss Evelyn over at Impact Math 19. Okay, she usually comes on at 1 p.m. Central Standard Time. Okay, so keep that in mind. And if you are trying to be a nurse and you need some guidance, especially how to do dosage, I mentioned her before, make sure you reach out to a blessed RN because she is amazing with those things. Okay? All right, not a problem. It's next month. Okay, so you're thinking about next month? All right. All right, so we're just going to need to step it up, all right? Because we got some work to do. All right, so I think that's all I have for you guys. Yep, that's all I have for you guys. And be on the lookout because soon enough I'm going to re-release my courses. So at least you have something for the summer if you do need to go a little bit further into it. Okay, so if you want to learn a little bit, maybe you have your son, your niece, your nephew that's about to go into high school and you want to make sure that they're ready for high school math. Or if you know somebody that's going to go back to the community college and they haven't been in the classroom since they were a fetus, I totally get that. You might want to do like a pre-course before you take those courses because those community college courses goes really quickly. Okay, so I will be conducting like a pre-community college math course this summer. Definitely going to be doing that. But yeah, just keep an eye out. Yes, yes, and good morning. All right, so I'm going to wrap up. I'm going to download and I'm probably going to see if I can upload the video possibly like 9, maybe 10 a.m. Eastern Standard Time. So today's live will be uploaded today. All right. All right, guys, thank you so much. Thank you for the gifts. Thank you for coming and paying attention to me at like 12:44, double numbers, on a Wednesday. Well, no, a Thursday morning. So I always pray that you guys are going to be doing well. I always pray for your drive and determination, especially on days where it's tough, that I really want you to do well. And I know you're going to do well because you're here and you're awesome. All right? Okay? All right. Love you guys. Have a good morning, afternoon, evening, all that jazz. All right. Talk to you soon. I'll see you tomorrow.